The first item is two informal resolution agreements of pest control incidents that were presented by staff. So the first is case file 24.166 Brightview. This is the third level of enforcement action for failure to register agents, and it was agreed to an informal resolution of $1,400. And you should all have that as attachment 1A. The second case file was 24.167 NEA Turf Care. This was a major violation due to agents making pesticide application with lack of PPE, and it was agreed to a formal resolution of $600. That's attachment 2A. So the committee voted unanimously to present these resolution agreements to the plant board for final approval. So I'd like to make a motion to approve the pest control committee recommendation to accept the two settlement agreement resolutions.
Second.
Thank you. You've got a motion and a second to accept the pest control resolution. Any questions, comments? Second on this.
Did he make the motion?
Yes. Forward.
Yes, he did.
Yeah, he did.
You made
Yeah,
it.
that's great.
He did, and I think.
Okay.
Round line. Any questions, comments on the pest control resolution? All those in favor, signify by saying aye. Opposed? Motion carried.
All right, so the next item of our business was, or I'd like to present anyway, is the minutes, and these are attachment 2D in your package. So I'd like to make a motion to accept the minutes, the May 28th, 2024 Pest Control Committee meeting.
You have a motion by Dr. Ford, second by Mr. Alford to accept the minutes of the pest control committee meeting. Those in favor, signify by saying aye. Opposed? Motion carried. Dr. Ford?
All right, final item is pest control examination reports. And I would like to make a motion to accept the pest control examination results for the months of March 2024 through May of 2024. And again, you have that as attachment 3E.
Second.
Mr. Alford, you have a motion by Dr. Ford, second by Mr. Alford to accept the pest control examination report, results. Any questions, comments? All those in favor, signify by saying aye. Opposed? Motion carried. Dr. Ford?
Mr. Chairman, that completes our report.
Thank you very much. Let's keep moving on. Next committee report, from the pesticide committee.
Thank you very much, Mr. Chairman. Our committee met on May 22nd, 2024. I appreciate Matthew Marsh for stepping in and chairing that meeting. I had to leave after we started it to attend the funeral. Pesticides Section Enforcement Program Manager Lee Gibson provided an overview of case file documents and investigation procedures, and we went through that. Staff then presented 16 warning letters and 5 civil penalties to the committee for review and recommendation to the board, which you have those in your packet. They've been mailed out to you. The committee voted to present the enforcement actions to the plant board for final approval. Garrett Frost recused himself from enforcement actions on 1, 3, 8, 15, 16, 17, 18, 19, 20, and 21. All right. So, there's, said these have been mailed out to you. There's nothing controversial about these. I would like to make a motion to approve the pesticide committee's recommendation to accept the enforcement actions.
Second. Got a motion second to accept the enforcement actions from the pesticide committee. Any questions, comments on those enforcement actions? Hearing none, all those in favor, signify by saying aye.
Aye.
Opposed? Motion carried.
Susie provided an update, an example of the new semi-automated license database and process, and that's also an attachment in your file. She then provided an update on the general information about drones and the types of licenses that are needed, FAA requirements, and contact information regarding the use of drones for pesticide applications. So, with your permission, Mr. Chairman, we'd like to introduce to you Dr. Jason Davis, who is part of the UAE Systems Division of Ag Cooperative Extension Service. He's also assistant professor in remote sensing and pesticide application, to talk to us a little bit and educate us some more about this exciting new way we're going in aerial agriculture. Dr. Davis?
I don't know. We'll see about the slide.
Okay.
Should be fine. I think they're bright enough. Good morning.
Morning.
I appreciate the opportunity to come visit for just a moment about some of the quickly evolving technology that you're seeing in production systems and kind of where we see the limitations, where our understanding sits today, and some future opportunities to maybe intersect and interact with these technologies. My name is Jason Davis. I've been working for the Division of Agriculture for 10 years now, primarily in the pesticide application technology area, where I work with whether it's nozzles and pumps, calibration, automated rate controllers, those types of things, the technology side of pesticide application. In the last 5 years, I've worked with remote sensing technologies, primarily drones, imaging drones. And in the last 3 years, I found myself at the intersection of the two. So pesticide application by drones. And so that's what we're going to be talking about this morning, is applications with RPAS, remotely piloted aerial application systems. That's the technical term from the FAA regarding spray drones. And so I have a fairly regular conversation with applicators over the phone, maybe 3 to 8 times a week, depending on the time of the year, particularly increased as of recent, related to I bought a spray drone, now what? Or I'm looking at buying spray drones. And so there's a very poor understanding of how to operate these drones effectively. Although we'll talk a little bit about how, relatively speaking, they're fairly simple compared to, say, flying a manned aircraft. And so why is there appeal to these new technologies? So let's take a look at some of the reasons why an applicator, a producer, or a commercial pilot might be interested in adopting such technologies. One, they can get places that a manned aircraft cannot get, or where a ground applicator cannot get, a time window, whether because of the ground, the flooded field, or soft ground. And so there's an access to application timing or application safety that these craft fall into. And so there's a higher level of safety or, again, field applications that we can't do in other means. They're also, relatively speaking, easy to obtain. If you compare the cost of one of these machines to an ag cat or a ground rig, they're significantly cheaper, okay? And so the technology is there, it's accessible, and it's easy to obtain. You could go to any number of spray drone manufacturers or distributors in Arkansas right now, and within a matter of weeks, have hardware on the ground ready to go. Okay, so it's easy to get. They're very nimble and they're automated. You can pre-program a flight or for a field, push a button, and it will execute that flight plan autonomously. This is, and I've categorized it this way, and I will stand by this for the next few years. This is the first wave of commercialized agricultural robotics. It's a dynamic shift for us. This is not a man behind the wheel or behind the sticks flying this aircraft. It is software controlled, artificial intelligence assisted craft. And so what this looks like moving forward is dynamic. The platforms, the navigation capabilities are going to change quickly. However, there are some drawbacks and limitations as where we sit today. One, the current battery and payload capacity of these craft limit field efficiency. Most of them are in the upper limits of 10 to 14 gallons on a payload. That's nowhere near what, say, an 800-gallon tank on an air tractor can carry, right? And so the fuel efficiency goes down. Most of them, and I'll talk about some of the calculations, will fly for between 10 and 15 minutes before they need attention from a person to up the payload or swap the battery. And so there's some limitations on how many acres we can cover. So the field efficiency compared to a manned aircraft or a ground rig is very low. The number of acres you can cover right now. And also regulations are weakly developed and poorly understood. This is across the country. This is at the FAA's level and in most other states we've discussed with. And so this is not something that Arkansas is behind on. It's regulations in general are behind. And so again, part of that is the technology that we're looking at regulating and understanding today is very different from where it was 6 months ago. And so it's dynamic. There are also emerging safety concerns with interactions in shared airspace with manned aircraft operations, right? There's a discussion to be had about imaging drones because of the altitude they're flying at, but also where these aircraft are in relation to manned aircraft and the communication bridges that we need to create moving forward. Because there's certainly limitations on what I, as a pilot on the ground, remote pilot, can see what's happening over the next tree line. And so for a manned aircraft to dip into that field, it's hard to predict that. There's no clear communication right now, although there's some evolving technologies that hopefully can help with that. And so today I would like to walk through a little bit of what the conversations I typically have with applicators as they're trying to grapple with the technology as well as the regulations. Would also like to have a discussion about the practical applications of these technologies in our production systems, potential regulations that we might consider from a very pragmatic standpoint in the context of what the technology can do and what the applicator has control of in these automated systems. And then some final thoughts on, again, the field efficiency of these systems and what it looks like moving forward. So if let's put this in the context of a boom sprayer. If you've got a ground rig or even an aircraft with a boom on it, we generally assume, now this board generally sees the worst case scenarios in application, maybe, but generally speaking, we have a lot of acres covered on any given day in Arkansas that are successful, and this holds true. Uniform nozzle spacing, consistent pressure, consistent fan angles, uniform application height and speed. These are things the applicator are worried about in the field. And generally speaking, in most applications, these are held constant or with minor modifications as speed changes, they can dynamically shift with a rate controlled system. And then we hopefully are operating in an environment where we have negligible wind effects and stable or consistent air movement that lend to the efficacy of that and then the limitation of off-target movement. And so I use this as an example. These are spray cards, droplet pattern from let's say a 15-gallon per acre application. And you could extend this from a 10-foot boom to a 120-foot boom. It doesn't matter. The droplet pattern would be consistent, right? If you apply those same assumptions to RPAS, remotely piloted drone systems, it starts falling apart a little bit. And it has to do with how the technology is implemented. We have what's known as an effective swath width. So we have a swath width, and then we have what is known as an effective swath width, which is narrower, requiring overlap between passes. This is more similar to like a pasture boomless nozzle configuration, where you have a tapered fan and you have overlapping swaths so that the peaks and the valleys of the product output overlap, providing a more consistent application. And so there's a big question here as the equipment changes moving forward in different platforms, what does that effective swath width look like? Additionally, these systems will kick on nozzles and off nozzles, adjust pressure, and then fluctuate the flow rates dynamically as needed on a 10 hertz or 10 times per second basis. So the pressure consistencies aren't there right now. They're using that to maintain rates. And so we can't count on that. We also can't count on the consistent fan angle again because of the dynamic nature of the boom nozzles coming on and off. And then also the dynamics of the wind at play at different altitudes. And so these again, assumptions start falling apart. Generally speaking, we can assume application height and speed. Most of these systems will not take off without RTK precision. So they know where they're at, their orientation in 3D space within about 1 centimeter or 2 centimeters. And they can dynamically change that based on the terrain that it's following, depending on the options set forth. So the speed and the height can be held constant. So if we get to the question of what is my swath width, this has been a question we've primarily been focusing with the commercial applicators that have adopted the technology. I started working in 2021 with some of our commercial applicators on this question. And we set up our swath width estimates very similar to what you might see with a manned aircraft, except for we've traditionally used droplet cards instead of the fluorescent dye and string, just because it's easy to drop these cards on a turn roll and measure the swath and go to the field. It's easy technology to estimate. And so here's an example of a T30 setup where we're looking at maybe a 20 or a 30-foot wide swath. And this is something, again, we started doing in 2021. This particular setup, I'm going to show you some spray cards to simulate what we see in the field and this dynamic shift that I've described earlier. So this particular example, we tried to hold as much as we could constant. Spray cards were placed at 2-foot intervals. And then here is a fine and medium droplet pattern. Now, let's set this up for a second. The center of this card, my laser disappears. The center of this pattern here is where the spray drone was flying. And these are replicated passes. This is identical passes here, right? So 3 gallons, 3 gallons, 5 gallons, 5 gallons. And what you notice is the droplet pattern shifting left and right. These swaths were within less than a minute of each other, subsequent passes. We just reset the cards and run again. And so again, the patterns that we see in the fields can be dynamic depending on the environment at play. And so that's one consideration that we hadn't looked at, as well as this is a coarser droplet spectrum, 10 gallons and 15 gallons. And again, you see the same thing. You see the patterns shifting around and moving. And so this is a concern, something we can consider. We need more data, more information moving forward, but some preliminary analysis to give us an idea of how wide applicators should plug into that controller. This is a question we're trying to help them answer. Now, notice the scale here. It's difficult to see behind the screen share notice, but we're looking at 15 feet. Most of the applications will try to push 20 to 30 feet. This particular setup we had this day, 15 feet was about all we could get. We had almost no droplet measurements outside of that 15 feet, 7.5 feet either side. Now, that has changed in 3 or 4 years. The technology has evolved and we've gotten much, much wider, figured out how to set up the craft better to have a more uniform pattern. But these were some of our early tests. And if we have a wind adjusted flight pattern, this is kind of what we work with our commercial applicators to find these dramatic fall offs so that we can say, this 10 feet in the middle is your application width, plug that into your controller, and we can have a uniform pattern across that field. And so this is the primary question our applicators are interested in, is how to maintain uniform efficacy across the field. What does that look like with my craft in these parameters? So again, some of our early testing. What's changed since 2021 is most of the modern craft, at least in the ones that's currently adopted in the field, have shifted from what you would see a traditional pneumatic nozzle system. So this is a boom sprayer nozzle system. We've shifted from one series of craft having this to a controlled droplet atomizer technology, which dramatically changes our patterns. We do get a wider pattern. Let's take a look at some of the results from that. One thing I have trouble with on these particular craft is that the manufacturer, DJI, listed these droplet categories when this sprayer hit the market. Fine, medium, coarse, extra coarse. Traditionally, these correlate to ASABE engineering specs in micron droplet sizes. Unfortunately, these were completely arbitrary. There was a pre-selected, you drop down menu and hit the button, and an applicator felt good about spraying extra coarse, but it meant absolutely nothing to any standard. It was relative to other settings, is all it was. They did an update, and I cried foul to several of the folks that were operating these craft. And fortunately, apparently other folks in the industry did as well, and DJI shifted the droplet categories. And so sure enough, what we were measuring in the field as extra coarse was actually a medium. And so there were some major drift concerns in that particular application system based on a software setting. So again, I highlight this to say a software update did this. This is not a nozzle change. This is a software update. And so the dynamic nature of this, again, is hard to keep a tab on. So with that, here are some of the earlier tests. This is supposed to be a fine and a medium. We see much more uniform pattern, and I'll get to some of our better looking pattern in a second, but we're measuring it 30 feet wide now. So we've doubled our swath width. This technology, this is a coarse and extra coarse. If you've ever looked at these patterns, you know very quickly that that is not an extra coarse pattern. But what we do see is, and here's a second disc they have, a little bit coarser still yet. But regardless, we got a more uniform pattern. We still see these fluctuations, these shifts based on the center plot line, but we're moving forward in technology. It is doing better. So we noticed the dramatic peak and fall within that 7 to 10 feet now has flattened out. And we've taken the same volume of water with the newer technologies and software updates. And we're able to spread a much more uniform pattern, much broader. This would be more like a 20 to 25 foot spray pattern. So where we cut these edges off basically. And so again, the technology changed. The setup and chassis have changed. Droplet dynamics have changed. And a lot of that has to do with software as well. So again, that's kind of where we're at on a scope with consideration with these technologies as of now. And if you go back, here's one thing to take note of. Look at the scale here, 0 to 5% coverage with these systems, because again, it's spread out. If we go back to that the other setup, all of that droplet pattern was in the middle, getting somewhere between 10 and 20% coverage. And so our coverage drops because it's the same volume of water spread threefold wider, right? And so there's a question there of, can we get efficacy out of 3 to 5% at 30 feet wide at X miles an hour? I set up all of that only to say there's a lot we don't know, right? And so this is chemical specific considerations. This is target specific considerations. There's still going to be modeling considerations and dynamic environment considerations in these new systems. And again, every few months, there's an update that changes the dynamics completely. And so it's very fluid situation. And so, in boom nozzle configurations, we maintain between a 50% overlap between nozzles at the target, 100% between the three nozzles. So essentially, this pattern has essentially 100% overlap in the middle, as you see. Boomless sprayers as well as spray drones, we recommend the same thing, pass per pass, pushing 100% from the total observed swath. So as an example, if we were getting droplets at 40 feet, you may end up just spraying 20 feet increments moving over. And again, this is a platform by platform configuration, generally speaking. So with that said, our conclusions on some of the swathing techniques, and again, just some of our background information, just for context for this discussion, that we recommend 100% overlap based on those tests. We see a positive correlation between spray volume and target coverage. The more water you put out, the better coverage you get. That sounds logical, right? But we had to validate that, at least to some extent. The coarser droplet spectrums appear to hold up better in patterns, and they appear to increase deposition, resulting in increasing coverage right now. Again, these are preliminary results. We seem to hold that pattern underneath the drone. It's not drifting off target near as bad. And so we're getting the droplets where we want them to go with the coarser pattern. But there's still a lot of research deficits. We just don't know in, again, this dynamic situation. So we've got to do a better job of evaluating equipment speeds, heights, and then particularly the canopy structure. And I'll show you a little bit of data of where we're at with that now. We've got a new technology that we've recently adopted Not a huge fan of the name, but Application Insights has put out a new patented technology, and I had to put this on the slide because that's what it's called, but it's called a swath gobbler. I don't know who came up with that. They have a sense of humor, but anyway, it's a little scanning box. It's similar to what you might see with the dye and fluorescent technology running through the string. Except for this is scanning bonded paper that's been painted with a spray dye from a spray dryer. And so we stretch out whatever length of paper we want. We've got a track system that's associated with it. And then it scans that and gives us a deposition percentage per whatever unit measurement you want to take. We've just received our version about 3 weeks ago. I've done a couple of small trials with it already. This is an example. And what I like about this is a continuous measurement, however you want to stretch the paper, basically. And so what we did is we stretched it through BlackBerry canopies in rows. And so we modeled this in 3D. This is 3D coverage from the ground over the top of the BlackBerry row and then down the other side. And then we sprayed the blackberries, and you can see a deposition of that, how it tapers as you get down into the canopy. And so again, this obviously has some unique implications for what we can do in row crops. We've just done it once in blackberry so far. And so here's a really quick video of that application. If you've not seen a spray drone in action, maybe. You may just get to see a picture of a spray drone. Well,
Let me try to click.
Yeah. It's okay, but yeah, there's a
Oh,
play
there
button
it
there.
is. I got you.
I don't think there's any sound here. This is a drone video in the drone.
You can play.
It's okay if not. I'll just not be interested in seeing it in action. These are fairly large craft. This is a T40, 40-liter tank. It's got 8 rotors, 4 arms, one a motor and a prop on the top and bottom of each arm. Very powerful craft. If you've ever been around one taking off, it makes you want to stand back a little bit. They've got some power behind them, so very impressive. So we have also conducted with Dr. Tommy Butts before he joined the Purdue team and Dr. Terry Sparlock. Last year, we did some efficacy trials with our commercial applicators to see what these drones look like in burn down scenarios. We evaluated basically the coverage on water sensitive paper as well as visual ratings and efficacy and biomass readings. And we evaluated the top of the canopy coverage from weed control samples applied to those treatments. And so the coverage, only data study collected, we had collected the water sensitive paper in a 3-dimensional pattern, top, front, and back. And actually, this is an image from Beam satellite imagery. Our trial, about 3 weeks later, got imaged and it's permanently embedded on the internet now. And so that was kind of interesting to see. I'm looking for a background image. The weed control study we used paraquat, apply it to naturally occurring weeds last spring. And so just a really quick summary, we looked at 3 droplet sizes. This particular craft is a T30. It's got six rotors, 6 arms, and it has the configuration. And so fine, medium, and a coarse. And we looked at spray drone at 2 gallons, 5 gallons, compared to a ground rig. In this case, was a Mudmaster, 10 gallons. And so the highlight here I wanted to showcase is that if you look at 2 gallons, 5 gallons, and 10 gallons, these are percent droplets on those spray cards. At the fine pattern, we do see that the dramatic differences in those. But what we end up with a spray drone, we saw similar coverage from the spray drone as we did the ground rig at 5 and 10 gallons. So we got similar coverage and then actually the same efficacy we'll show here in a second. So we were very impressed by this. I did not expect all. But we did see a significant drop in coverage when it comes down to 2 gallon work. And so most of the gallons work that's going out right now is between 2 and 3 gallons. That's pretty typical. But we're seeing, again, similar droplet coverage and efficacy out of it once you get to 5 gallon work. And so here's that spray, one of the sites. And I'll just highlight, if you can look, the different treatments. I'll look at our ratings here. We had 2 gallon work, 5 gallon, and 10 gallon. Similar efficacy between, again, 5 gallon and 10 gallon. And then the biomass estimates, we saw no difference between any of the three. So at the end, the biomass estimates we took, were very similar across all gallons. And so again, early results, this is not in crop, this is again, a burn down application. But we were very impressed with it compared to what we had been saying before on the low volume application. And so results of that suggest that these craft operated at 5 gallons can provide equivalent coverage and weed control compared to a 10-gallon per acre application. The coverage was impacted more by the nozzle top as opposed to the application top. So actually, if you get your nozzles and droplet sizes right with the volumes, you could do a pretty good job. And then further research again is still needed as we update the swaths, the speeds. This was on the T30 series, the pneumatic nozzles. We've not looked at this with the lower coverage, wider swaths of the T40, just not had access and time to do that yet. And so, so this was last year's work. So that's context of what we have done the last couple of years so far. None of this has been funded work. Every bit of it has been what we could do in collaboration with the producer, the generous time volunteered by a commercial applicator, and then we try to get our teams to the field to set up the plots. And so all of this has been, so we've not had produce an awful lot of research at this standpoint because we've not had any funded projects in this space yet. So from a federal regulations perspective, when I receive a phone call from an applicator that's interested in pursuing this, there's really 3 things that they need to do. And this is, it's a gray process. It's not clearly defined. Not that the FAA doesn't have it clearly written, but if you've ever read FAA regulations and rules, it's not the easiest thing to navigate. And so there's not a condensed, easy way to do this. But essentially, they need a Part 107, which is just a drone operating license. They've got to be able to fly a drone legally with Part 107. This is fairly simple. It's a 60-question exam you take at a local airport. Secondly, they need a Part 137, which allows them to spray and spread things from the craft. So this is an imaging drone license. The second one is you're going to release something from that drone, spray droplets, spreader pellets. And so that's what a Part 137 is. And then lastly, you have to apply for a 44807 waiver that allows you to operate a craft greater than 55 pounds. There are very few, I can think of one right now, craft that with a payload and battery weighs under 55 pounds. So almost everybody that's going to be in the field using these craft will have to have that waiver as well. Now, I'm on the FAA's FAST team and discussions are at hand right now. We estimate in Arkansas, and we don't have any good hard numbers, but this is based on phone conversations with applicators and the distributors, how much craft are going out. We're at about 30 to 40% federal regulatory compliance in Arkansas right now. That means there's a lot of craft entering Arkansas airspace that may be in process, because this takes time. This is not a over the weekend process. They may be in process. I would guess there's a significant percentage that's not. And so we have some willful non-compliance at this point, or maybe ignorant non-compliance. I just don't know is probably more likely. And so there's an opportunity for an educational gap to be filled there to make sure everybody can get up to speed. So that's at the federal level. From the state right now, this is the current, what's been posted online, I believe, and then what we've kind of followed and summarized. 2 categories. If the air applications are made by our commercial application, you need to be a commercial firm licensing with aerial category, including insurance. You got to have an individual commercial license with aerial category and other applicable categories for agricultural planting. If it's an individual, you've got to have a private applicator license with pilot authorization. So currently, these are essentially treated, and correct me if I'm wrong, but as manned aircraft operators. So we've got a pilot category, again, that's very different. but it's treated as a manned aircraft. And I'm not saying that's wrong, I'm just saying that's where we're at now. Here's your current equipment check for manned aircraft in the field. And I've adjusted this for rotary aircraft because it makes the most sense in this context. But I've summarized this in these bullet points. So if you've got an inspector that's approaching an aircraft and they're gonna do an equipment check, this is the checklist they have. Less than 145 miles an hour. Spray drones have a max speed of 25 miles an hour as dictated by the FAA. And so that would be something that is easy to comply with, but there maybe need a special consideration to adjust for in the state, something to consider. And so I would consider that one easy to check, but again, may need some modifications if you create a new category. Less than 15 foot above the crop canopy, that's, most of our applications are between 10 and 12 feet. There may be opportunities for go 15. There really should be no reason an applicator should be at 20 or 25 feet. It doesn't make sense. And so that one's easy to be compliant with. This is a no-brainer. Any temperature applications from any applications into temperature inversion should be avoided, no matter, regardless of the craft. Specific drip reduction nozzle considerations, that would be something that I would think would be easy to list in a regulation. But it's gonna have to have special consideration for the craft, because what that looks like based on the craft that's entering the market, it's gonna be, again, dynamic. And it may be, hard to model that without measuring droplet size on the turn rod, depending on what software version you're on, basically. And so application rate of greater than 2 gallons per acre, again, that's pretty standard. Most of our applications are between 2 and 3. There are a lot of labels, and this is not a problem for this board, but there's a lot of labels out there that don't have either aerial descriptions on it or aerial and that enable these products to go out by any aircraft, or they require a higher gallonages. It's hard to obtain with this. So there's a lot of probably label non-compliance because the label says by air at 10 gallons and they're putting it at 2 because of the way their systems are set up. Medium droplet classification or greater, that's great, except for, again, if I'm clicking medium on my controller, that may not mean anything to that applicator. So it's just something to be aware of. Spray nozzle discharge by space rear of aircraft, 10 inch below the trailing edge of a wing. This really is this comes into play with droplet shear at a greater velocity, greater speed in the field. At 15 or 20 or 25 miles an hour, this doesn't play into this. So I think this could be something that in a new category would need to be removed in this context. Same with the wind shear angle of nozzle discharge. These all very much play into effect with a manned aircraft at 110 miles an hour, not so much with an aircraft at 10 or 20 or 25 miles an hour. And then it's hard to see that I recognize, but also you've got listed that the boom length divided by the wingspan has got to be 80, it's 0.08, 80% of the rotary on a rotary craft, I think is the way it's listed. I think everybody entering the market right now are compliant with this. I don't think that's an issue, but I don't know what that looks like going forward. And then secondly, I don't know, again, that since the travel speed that you're gonna be operating at, that this plays into effect. This would be a question we need to look at moving forward. It's a gray area for sure on these craft. And so some considerations as I'm wrapping up here. And I say regulatory considerations. What I mean by that is as an example, most of these craft are set up semi-permanently. Where the nozzles are placed are part of the chassis of the craft. So it's a matter of what drone they buy, whether they would be compliant with regulations. And so it may be hard to say your spacing of your nozzles needs to be 80% inside the wingtips of that craft, but the next model that comes out that they purchase, they can't modify that. And so it's not something that they can adjust. It's not a parameter they can change. So just keep in mind if you decide to move forward with something along those lines. These craft configurations have been approved by the FAA for airworthiness. And so if you modify that craft, it may void its airworthiness consideration. And so again, you're generally going to have to be modifying the chassis of the craft. And so I don't know that you would ever want an applicator to actually modify anything on that craft anyway. And so it may just be a matter of making sure that what's being purchased fits these categories. Most applications are also flown with automation. I say greater than 75% because there's a lot of special applications, levees, cutting up next to tree lines where an applicator may take over and manually fly that, or ferrying back and forth. Sometimes they'll take over manually while they're ferrying back and forth between payloads. But I would say at least 75%, if not greater, are push a button and go. And so that's not an applicator making a decision in real time. It's a code being executed. And so what they can control is their flight plan, what they upload to that controller. That would be their flight speed, their application volume to a degree, based on their pump size and nozzle configuration, the swath width, and then to a degree, their droplet size, although some of that's ambiguous in their control setup. And so here's an example screenshot of one of those controllers. And this is the input. Now, this slides up and down. There's a few more options here, but generally speaking, these are the ones that would be editable. The application rate, so 10 gallons per acre, the flight speed, the route spacing or the swath width, and then the height above the crop. So this is in that blackberry canopy we were at just not long ago. These are the things that they have a decision to make on that might be something to look at regulatory wise to set a ceiling on essentially. But that's about all you could control at this point, right? And the last thing here, I've already stated this, but there's a significant amount of what I would call ignorant non-compliance to current regulations. They don't know, or maybe they don't know, and it's enough complication as they do look, they don't want to know. And so there's a lot of that going on right now in the field. That's at the federal level and also at the state level. So field efficiency considerations. I think I've got one more slide here and that's about it. FAA max speed is 25 miles an hour for that 137. And so that gives you a ceiling that's already established by the federal government. Most battery and payload combinations will deplete between 10 and 15 minutes before they're having to return and be serviced by an applicator or a pilot. So if you kind of do the math, and I've worked with some commercial applicators to kind of validate these numbers, but at 2 gallon per acre rate on a 40 liter tank, 10 gallons, you could cover 5 acres every 15 minutes, 10 to 15 minutes. That's 20 to 30 acres per hour. These craft, one operator with one aircraft, the max, they're going to cover at the moment between 200 and 300 acres in a day. And that's a 10-hour day. That's a lot of labor. That's carrying almost every day. That machine and hauling a lot of batteries and running a generator continuously to charge those batteries. This is a very labor intensive process. And they're not covering a lot of territory in context with a manned aircraft or a ground rig. But again, they're not competing with them either, right? This is areas that the ground rig or a manned aircraft can't get to. So generally speaking, these costs, unit of time, cost per acre, 2 to 3 times what it might cost to get an aerial applicator or a ground rig into. But again, it's areas that would not have an application otherwise. And so the math changes as we adopt swarm technologies. And I would have thought a few months ago this was a little ways out there. That's not the case anymore. As of last month, there's a company named Helio that recently acquired an FAA waiver to do these 3 things. And this boggles my mind a little bit. They can do up to 3 platforms with 1 controller, so they can fly 3 drones at a time. I don't know how you can run around fast enough to keep them moving, but let's see. They can do this at night. And they can do that, fly areas beyond their visual line of sight where they can't see those 3 cars. What our airspace looks like moving forward when you have autonomous craft navigating at night with minimal visibility, I don't know. We've got some figuring out to do for sure. The other side of this, and this board knows well, temperature inversion has become a major concern. And so I don't know that the FAA saw that dynamic when they approved this waiver. And so the more of these applications we have, I'm afraid we're going to be walking right into a lot of trouble in temperature inversions and the dynamics that we've got in place. And so I'll just leave it with that. So, and the last thing improved communication with manned aircraft operation is absolutely critical. We have got to figure out the communication pipeline between that air tractor and that drone in the field. We're fortunate we've not had any interactions, maybe close calls that aren't made public, but no serious interactions. The airspace is getting busier. I don't know that that's this board's call to solve that problem, but I'm just saying, we in the agriculture industry have got to figure this out. So in summary, these systems have many advantages and disadvantages when it comes to application access to fields and times we can't otherwise get to. There's a lot of field efficiency limitations that are continually evolving and improving. It's very quickly evolving technology. It's a dynamic situation. Both federal and state regulations and the manufacturers of the chemicals have got some label updates, and we've got some regulatory updates that I don't know the answer to, but again, it's something we need to refine and then properly direct these applicators so that they're integrated appropriately into this system. This is not going away. They've got to figure this out. We need better understanding of application dynamics, how these equipment configurations and environmental considerations play into these applications and drift potential. We need applicators to be on board with clear, pragmatic regulations that they can follow. And then we potentially need a new category for equipment with applicable training. I don't know that that's the direction we want to go with that. Maybe we want to leave it as an aerial manned aircraft category. That's not my decision, but I think it's possible that there would be a category that has a tweaked test and tweaked training to provide an easier and more effective path for these applicators to enter the industry and be compliant. But right now, it's not completely clear. So with that, I will stop and entertain any discussion or questions you can have. Yes, sir.
I have a number of questions. Are there any labels now that contemplate drone applications?
There are, Susie may have specific examples. There are,
I mean, no new ones are being submitted
No.
now that they see drones.
there
taking
are
off.
very, if at all, there are almost no, I don't say none. There are almost no labels that spell out drone applications at the moment. That I'm aware of.
I'll chime in.
Yeah, go
As
ahead.
of right now, because we have been talking with EPA, we have not seen a label that references a drone. We have heard there are maybe two out there that have a special, what I call a supplemental label that reference equipments and reference drones. But at this point, I just want to remind everybody, it's up to the manufacturer of the pesticide to request that be put on the label, not EPA to just put it on the label. So that's just something I'll remind everybody as we start talking about this. But right now, we have not seen drones referenced on the label.
Got another one. When you were talking about percent coverage, and I saw, between 1 or 2 gallons versus 10 gallons, which again, I don't know anybody putting them out
Nobody's
at
putting
even
out-
5 gallons. Most are going out at 2 gallons that I know of.
Right.
How does that compare to an airplane and a boom? So what's normal for the average boom sprayer and what's normal for the average airplane?
The average ground sprayer would be more in the 15 to 18% coverage. And I say a 10 to 15 gallon per acre. But again, that's you're quadrupling, if not more, the amount of water that's going out, right? Air tractor would be probably closer to that 5% coverage. And again, that's dynamic, right? We've got some things that's a very general statement. And so, but there's still, we need to look at, we need to do those direct comparisons, and spray cards are not the best way to do that. There's better ways to do that moving forward. A lot of what I've shown now is preliminary. So what we've done kind of on the turn row, but those trials need to be completed formally.
In your part 137 discussion of things that match up and things that don't match up, you talk about rotary aircraft, which I'm assuming are just the helicopters. It has nothing to do with the planes. What's the difference? I mean, what's the purpose of having only the 80% boom of the rotor? What's the purpose in that? It would seem that would whatever it's meaning there, it's trying to accomplish there, would be more relevant to a drone than anything about an airplane.
That's why I had a question mark there.
Yeah.
Because I'm not 100% sure we would fall on that. We'd have to look at that. But generally speaking, that has to do with the vortices pushing those droplets out and outside of the intended area of application.
Which happens on an airplane.
It happens on an airplane.
But it's almost like it's designed to
It's
happen.
designed to happen.
Yeah.
It's in those setups are designed to, you have a swath that's wider than the wingtips, right?
Right.
And so, but when you get outside of that, it becomes less predictive, right? And so I think the dynamics that set up there are confined to that to optimize the efficiency of that swath. And so, again, that may very much play into that, but we have not looked at that. And so I put a question mark there. As far as regulations, it's an area we need to explore for sure. I've not seen any studies on an 8-rotor inverted craft, what it's doing versus a single prop helicopter. I would like to think the dynamics would be similar, but probably have some special caveats.
Do any of the drones that are in operation have a stationary vortex generator? I'm gonna call it a fixed wing behind it that's made to roll that chemical out, or is it only depending on the vortex created by the rotor?
To my knowledge, all of them are currently configured using the vortex created by the props.
Thank you.
Good
Real
questions.
quick, everyone, in your packets, you have an informational sheet I put together. It's attachment 3, it's on drones, it's information we give out in this office, it's what I shared with EPA, and most other states now have this also. It's just general basic knowledge on what's required.
Do any other states have any regulations, so you're aware?
Not that I know of, a lot of states have been calling Arkansas because of our Aerial Applicators Association. We have one of the largest and they're very active. So historically, Arkansas has taken the lead on a lot of aerial matters. Mark Hartz, before he left the board, was working with the National Aerial Applicators Association. They were putting together some issue papers and concerns. And they actually did comment on the swarm, in the night spraying, to my understanding, they did provide comment to the FAA. I just don't think they were utilized in the decision-making process. But Mark Hart actually stopped by a couple of weeks ago and gave me a packet of that information. If it's something we need to start bringing that organization in, I'll give y'all more updates we can.
But Susie, correct me if I'm wrong, states in our region are similarly
Yes,
providing
I'm sorry.
oversight and licensing like we are.
Yeah,
They're-
the only thing I
They're doing the
know,
best they can with what they have in place.
only thing I know that's been done is there may be tracking the equipment by the plane versus drone. So they know which is being licensed. For example, right now, our current licensing system, I can't tell you how many drones we have because it's classified air and ground. Now, moving forward next year, we're gonna see if we can at least update our database to tell y'all how many drones we have licensed. But right now, I'd have to just start doing a hard hand count and, you know, we didn't envision this when we were making updates. So that's the main question I'm getting is any states that have done anything, they have just whatever they're already doing. See, this is drones now instead of an aircraft.
Dr. Davis, question about the air getting busier, and I'm not a pilot but this may be a dumb question to address, but with it getting busier, with the swarms, is there some type of communication where a manned aircraft might, I don't know, like IF, friend or foe, something like that?
As of September of last year, there is a federal requirement that we broadcast a signal of where we are at. So spray drones and imaging drones. That is broadcast by a cellular network and posted online for manned aircraft to access. Now, how many of them access that information? I don't know. I can't say that. The problem is the way the regulations at the federal level are written is that the drones are, for umpteen reasons, the lowest on the category. We're supposed to see and avoid, get out of the way of an air tractor. But the communication's one way. They could possibly know where we're at. We have no idea. They're not not all, but many are not transponding a signal for us to receive and to be able to see them on a controller, we have to rely completely on ground observations and watching, and we do that. But to know, I will see every airplane at 30,000 feet on my controller and I'll get a warning. But I will never see the air tractor coming in at 145 miles an hour over the tree line.
I have a question. If you got through answering his. So on the liability insurance or the insurance that you have to have, since we're dealing with technology and sometimes that can go awry, where does the liability fall? If that drone miscalculates or has a crash, or especially in the 3 tier that is out of the visual line, I'm assuming it would fall on the who owns the pilot license. I would assume that's where it would fall.
I think that will be decided in court one day.
Software or the applicator, what would it be?
Our aerial applicators, people for hire, commercial firms do have to have insurance for the firm. However, a private farmer who is flying one of these, our law does not require insurance.
So if it drifts, or if they're just putting in the rate, a map, and letting it fly, and there's a variable there, the wind picks up or whatever, and it drifts, and it's a farmer, where,
That would fall on a drift event would fall on the shoulders of the applicator to make
Yeah.
that decision. It would be their responsibility to shut that crap down. So they have full authority in that situation to take over. I'm just saying that most of these, that's part of the appeal, is that you push a button and it does its thing. But yeah, from a drift standpoint, the responsibility would fall on the pilot, for
okay,
sure.
okay, thank you.
But as far as a software glitch causing an
Right.
incident, I think that's a to be determined question, for sure.
Okay, all right, thank you.
Question for you. We were speaking about collision avoidance earlier.
Mhm.
Were you, referring to ADS-B or something else?
It's a software, because we don't have ADS-B on our controllers. But we link to a server and with these systems. And, it's kind of an automated deal. It was a software update that was happening. I'm not sure exactly where it's posted, but it posted on ADS-B. That's not, I'm not on the manned aircraft side, so I don't know the receiving end of it. I just know that we're required to be connected to that server and it's our locations automatically broadcast. So I can follow up that and get that information to you. And off the top of my head, I'm not sure where you would access this pilot.
Okay, thank you.
Yes, sir.
Following up with what Robin said, is there even insurance out there available for aerial application by drone?
I know in order for a commercial firm to get a license with us, they have to meet our insurance requirement, and we do have some license, so for a commercial firm,
So,
yes,
okay,
but that's our requirement.
right. But there's an insurance company out there that's writing a policy for at least commercial
Yes.
drone applications.
Yes,
And do any of these drones, just thinking through the temperature inversion and some kind of record keeping of whether there was or wasn't, do any of them have temperature sensors where it might be required that, look, in 6 places around this field, you fly up to 50 feet and have to record and keep those temperatures, and we'll know if you took off in
Yes,
inversion.
those flight logs, most of the craft have, temperature, humidity, wind direction and velocity ratings that's recorded in those logs.
Okay.
So actually, in that situation, there's nothing gonna warn at this moment I'm aware of, that's gonna warn the applicator about that, but that is being collected in real time. So maybe that's something that moving forward could be, but from a regulatory standpoint, I think you could get those logs.
But you might even have, not even in contemplating in a regulatory standpoint, but you may have a better tool to know if there's a temperature inversion than you do running a boom on a ground rig. Because you can fly that column in certain spots in the field and say, yeah, well, I see it, it's obvious.
In the future, a software option could be implemented, certainly it's outside our control, but absolutely to monitor that and warn an applicator about it, for sure. Because we get wind velocity warnings, we get all kinds of warnings on the controller when the environment is at play that would negatively affect the application, but I don't think at the moment that temperature inversions is on the radar, but I can certainly see that being an opportunity moving forward.
More questions for Dr. David? I guess I'm there too. I think, obviously there's a lot more questions than answers and it's developing very fast. Before this board goes into making any kind of new regulations or rules, and we're obviously gonna have to have a lot of help, and some input from a lot of different, people involved, but Jason, on your, you had a slide, some of the things that we might need to modify in our current regulation to help people become compliant. What would some of that be, or you may have to get back with us on some of that, just so I think the first thing to do is work with what we have before we go off making any other rules and regulations.
And the only reason I brought up the equipment check, Susie and I have been discussing whether that's relevant to these new craft. And so as a starting point, if you have applicators that are fitting into this category because that's where we're at right now, and you have an inspector that's looking at those craft, can you even use that checklist? Is it relevant? And so that was my first stab at maybe not. Here's some things to consider. So I think there's certainly a discussion to be had moving forward, whether that's a separate category, an exception checkbox. We're working with spray drones, so use alternative DS. I don't know what that looks like, but I certainly think it's worth considering modifying that to be more applicable.
I think we welcome your input.
I'd be happy to help.
Maybe our committee will be jumping into this is one reason we wanted to have Dr. Davis here today, just kind of prep everybody for what's coming. And it's coming fast and furious. And Dr. Davis and I talked before the meeting about do some additional research, find some funding for this research that he's trying to do. I think we can acquire that and hopefully speed this up.
Is there somewhere on the website that helps with some of the regulations? Pretty shocking that there's, not as many people like actual registered for the drone pilot. Is there,
At the FAA level or at the state level?
at state level, like, is there anything? state
Well,
level
our
to
rules
help?
are posted on the website. Our aerial guys are very familiar with the aircraft setup. A lot of farmers I talk to get real quiet on the phone. Because when I start referring to our aerial rules, the first thing they say is, can a drone even comply with those? I don't know. That's why I had to call him. I don't have to tell our inspectors to check for some of these things. It's just basically written in the rules. I'm referring people, anybody that calls, we're giving them copies. As far as it's being abided by, I don't know yet. We're not getting a lot of what I call specific drone complaints, but we typically don't know if it's a drone or ground or air till we get out there. This is the first year we're getting a lot of calls about drone license. In the past, it's been one or two. We're getting a lot of calls this year, so I think we'll start seeing how this plays out this fall as final complaints come in.
I think you had 3 to 5 drones operating in previous seasons in the state. I think this year you're approaching 100 or more.
I have a lot of farmers are calling us this year. That's the uptick.
So dramatic uptick in adoption. Thank you all very much for that.
Thanks a lot, Dr.
Thank
Davis.
you.
Mr. Chairman, just to finish our committee report, Director Bray provided an update on a webinar regarding the future crop use of dicamba. I don't know if that's gonna be in your report later on, because it happened after our pesticide meeting.
It did, and I can go ahead and give a real quick update
Yeah,
right now.
don't mind it. Thanks,
Scott.
Scott.
Do that in other business, but that's good. So as I did speak to the pesticide committee, I want to make sure everybody understands that, the 3 in-crop dicamba products that were vacated by that ruling, no party challenged or appealed that decision. So that decision is pretty much locked in. Those products are out. Bayer has submitted what they're calling a new in-crop product for registration, and it just finished up a 30-day public comment period. I think it ended Monday. So that is the initial phase of the new registration process. So it is in motion at EPA to be registered. We have been told by EPA and by the Ag Law Center that process And FIFRA actually requires a minimum of a 17-month review period. So that product Bayer has submitted for registration is about a month into a 17-month registration process. BASF yesterday submitted another very similar product that has entered 30-day comment period, and it wraps up, I think, July 5th. So it is in the initial phases also of that 17-month review process. So there are two new in-crop products that are in motion for registration. But by all accounts, they will not be registered at least by September or so of 2025. So we're still looking at next year, the growing season, of not having a registered in-crop product on the market available. Sorry.
Are they just, I mean, what do you know about these products? Are they just dicamba with a better package, or dicamba plus something?
I'm not that familiar at this point. What I have seen is it's very similar to the original products. They're just tweaking the use labels, mainly, cutoff times for soybeans especially. Yeah. So.
Did I hear something, perhaps an additional agent added to the product on that?
I have not seen that, no. So these labels are subject to tweak after 30 days after comment period. So we really don't know what they're gonna look like for sure until EPA reviews the comments and the registration process makes its way through. So, my guess is the biggest change will be, cutoff periods, especially with soybean. I've heard rumors there might be some discussion on, is there a way, a workaround to have something in play for next year's growing season, but I don't know of anything, and I don't know. That's just rumors I've heard. All of the best information I can give you and give the farming community of Arkansas is right now, it does not look like there's gonna be a in-crop dicamba product. That's all I have right now. I wish I had more, but you know, it's all in motion and subject to change, so.
Thank you, Scott.
We'll keep you updated.
Appreciate that report.
Thank you. Yes, sir.
Last thing I have, Mr. Chairman, is just, I'd like to make a motion, to accept the minutes from our May 22nd, 2024 pesticide committee meeting.
Second.
Got a motion and a second to accept the pesticide committee meeting minutes. Any discussion, comment? All those in favor?
Aye.
Opposed? Motion carries.
Thank you very much.
All right, the next thing on the agenda, we have the Bureau of Standards Committee report from Mr. Lawson. I think you got that packet in front of you. Ms. Lawson.
Thank you. So the Bureau of Standards Committee met on May 14th, 2024, and the staff presented 96 civil penalties to the committee for review and recommendation to the board, which is attachment 1, which is, comprises on 79 for expired and no detail on table 1, 5 for misrepresentation of costing on table 2, and 12 for water contamination on table 3. The committee voted to present the 96 civil penalty actions to the full board for approval. I would like to make a motion to approve the Bureau of Standards Committee recommendations to accept the civil penalty actions.
Second.
Thank you. We've got a motion and a second to accept the civil penalty action to the Bureau of Standards Committee. Any questions or comments? I know you have these to review and maybe a question. Hearing none, all those in favor, signal by saying aye.
Aye.
Opposed? Motion carried.
And thank you. The last thing is, I'd like to make a motion to accept the minutes from the May 14th, 2024 Standards Committee meeting.
Second.
Got a motion and a second to accept the minutes of the Bureau of Standards Committee meeting. Any questions or comments? All those in favor, signal by saying aye.
Aye.
Opposed? Motion carried. Thank you, Ms. Hall.
Thank you.
I think that concludes the business we had on the agenda, for today. Anyone had business to bring before the board before we adjourn?
Mr. Chairman, something I meant to mention while I had the floor, I forgot. I wanted to just FYI, give y'all an update on pesticide compliance. As of this morning, we have received 92 total this year. 4 of them are alleged dicamba. Compared to this day last year, we had 133 total, just 17 alleged dicamba. And the previous year, 22, was much higher than that. I don't have those numbers on me, but last year, we settled back down into the 200s as opposed to the 400s and the 500s the previous years. So this year's trending just a little below we were last year as of today.
Good. Any other business for the board? You got to set a date for the September board meeting. Get out the calendar and kind of see what the schedule looks like. We'll probably maybe try to keep it in the first 2 weeks there. If we got some time, if we need to move it around, but, anything, the test, the first Thursday in September, that's kind of where we were here in June, that work with everyone. With no objection, we'll say Thursday, September 5th will be our next full board meeting. And I guess we're finished here today. Anybody have a motion to adjourn?
So move.
Second.
Everybody.
Those in favor?
Aye.
We're adjourned. Thank you.
Recording stopped.
Y'all like these 9:30 starts?